Welcome to our general information session. I'm Dr. Small, Executive Director of A Stronger Foundation. The following content intends to educate parents and inform education advocates on productive educational practices that enhance learning achievement and foster readiness for the real world. The information about the brain's general role in education is public knowledge and does not represent medical advice. I am not a medical doctor. The education system has derailed. As a doctor of education, I will share my perception of solving educational problems and educate parents on the sensible strategies for navigating such problems. We must see education as a life source to foster economic stability, mental well being, and lifelong success. Therefore, in this video, I focus on the significance of education and mindset enrichment in developing a stronger foundation to foster a more productive, fulfilling, and meaningful life. While other education commentators focus on the problem in education, I will focus on helping parents and education stakeholders understand the source of the problem and how to navigate a child's education to the highest capacity to yield their greatest potential. Throughout the general information sessions journey, my audience can expect four main takeaways, including a sensible explanations for children's behaviors during learning, an understanding of possible sources of their children's specific educational experience, a gain of the knowledge to redirect children's learning to transform failing into excelling, and learn insights for navigating unproductive education practices. Let's begin by discussing the parts of the brain related to our discussion. Feel free to take notes as this content will represent the foundation or prerequisite for connecting most of the content discussed in subsequent sessions. Let's begin with the frontal lobe. The brain's frontal lobe is located just behind the forehead. In this area of the brain is the executive control center where planning and thinking occur. This area functions in monitoring higher order thinking and problem solving. Most of the working memory resides in the frontal lobes, and it is the area where focus occurs. And the central Knowing the role of the cerebellum and the cerebrum is important to our discussion. These two structures play a role in thinking, learning, and memory. Now let's move into another important brain structure impacting learning and knowledge acquisition. The limbic system regulates self-will and the emotional system, including anxiety and motivation. I will unpack this information. Simply put, the general role of the limbic system is to generate and process emotions. I will now discuss the central role of the limbic system and each structure within the limbic system. Within the limbic system are four parts: thalamus, hypothalamus, hippocampus, and amygdala. This system involves generating and processing emotions as well as memories attached to emotions. I want you to note an interesting fact about the limbic system, mainly its location in the brain between the brainstem, which regulates breathing, heart rate, blood pressure, sleep and wake cycles, etc., and the cerebrum, which is more aligned with the reasoning section in the brain. This precise location of the limbic system, again between the brainstem and the cerebrum, permits the perfect storm between emotion and reason. Or I could say that it fosters a constant dilemma between irrational elements and common sense. Each of the four parts of the limbic system has a crucial role in learning and memory. Here is the breakdown. Sensory input from the environment constantly comes to the brain to be processed. Aside from smell, all incoming sensory input enters through the thalamus area of the brain. This entrance is like the doorway where all input from the environment enters to get to the various brain regions for processing. Now, since all input enters the thalamus, this means that both cognitive and irrational input share the same entrance into the brain. I want to add a little side note here to keep you following along the same wavelength. Imagine approaching an entrance to a building at the same exact time someone else is walking to that same entrance. What usually happens is that someone must yield to avoid a collision. In normal circumstances, one person stops because both cannot enter at the same time. The central role of the hypothalamus is to keep the body in its normal state called homeostasis. Another term for homeostasis is balance. An example of homeostasis is when the body automatically breaks into a sweat. Once through the thalamus, input passes through the hypothalamus where it is scrutinized for threatening content. Because remember, the hypothalamus's role is to maintain homeostasis. This means all information entering the brain gets checked out to determine whether it poses a threat. A central role of the hypothalamus is to keep the body in its normal state, called homeostasis. Another term for homeostasis is balance. An example of homeostasis is when the body automatically breaks into a sweat to normalize an elevated body temperature, or the way hunger signals promote eating to restore abdominal comfort. It's important to highlight that if the body system slips out of balance, focus and concentration becomes difficult. This is why when people are sick physically, emotionally, or even mentally, focusing on work or any form of deep rational thinking becomes difficult. So it should come as no surprise that if both logical and emotional elements approach the figurative entrance, as we discussed in our example, the rational content would yield because emotional content is prioritized and cognitive processing takes a backseat. Now, before moving on, I will review the thalamus's function as the entrance for information entering the brain. Because all input enters here, signals from the cerebrum involving thinking, memory, speech, and muscle movements also enters through the thalamus. Incoming input enters through the thalamus and moves to the appropriate brain section to be processed. However, before distribution throughout the brain, every signal first passes through the hypothalamus, which monitors incoming sensory input to determine threat levels, if any exist. We can later discuss its response when the threats are detected. But our takeaway is understanding that all signals, whether sensible or non-sensible, compete for a prioritized entrance at the same location. The hippocampus is the next structure to be discussed. The role of the hippocampus is gathering and transferring learning from working memory to long-term storage. The information or knowledge is analyzed to expedite the storing of new and old information. Upon scanning the brain, the hippocampus determines if storage through assimilation of already related stored material or accommodation of new knowledge must occur. Therefore, the learning is compartmentalized in the working or temporary memory region and then disseminated to appropriate areas for long-term storage. And by the way, long-term storage can take days to months to be completed. The final part of the limbic system I want to discuss is the amygdala. The amygdala is the most influential element of the limbic system impacting education, in my opinion. Although research on the amygdala's role in emotions is ongoing, a lot is already known based on present research. A quick summary of the amygdala's role in sensory input. Earlier, I mentioned that as the information enters the brain through the thalamus, it is examined for threats by the hypothalamus. The specific role of the amygdala is to determine how the individual should respond to every incoming signal. Therefore, the hypothalamus is concerned with maintaining homeostasis, balance, or normal conditions, and is ready to act if anybody's system is thrown off balance. Then the amygdala determines whether the individual needs to fight, flight, freeze, or engage. It determines if it's safe for the individual to interact with the input. Here is some necessary background on the amygdala. Fear is the leading emotion affected by the amygdala. It scours every input for any threat to survival. Then it modulates interaction with the environment. Now, I will introduce the classroom as the environment. The amygdala inspects every input to determine the appropriate response, whether to fight, flight, freeze, or engage. A significant learning obstacle is the fear of failure. Children are afraid of failure. But why is fear a factor in the classroom and environment? And how did this fear generate? The proper response entails trust versus mistrust elements experienced between birth and age 4. However, I will focus on the contributing factors that evolved during the K through second grade school years. Children begin to internalize inferiority in learning episodes. One frequent way the inferiority complex evolves is through classroom interactions when children realize the learning gaps between their peers. Here's how this looks. From the first day of school, as children observe each other, they realize who has a stronger education to read, write, and socialize better. They engage in a natural classification of the fittest and find their place in the hierarchy. In other words, they know their rank and naturally submit subconsciously to the higher achievers. And yes, the amygdala is the source of this order that dictates the child's engagement and restricts any attempt to challenge the order due to fear of threats to survival that could result from homeostasis imbalance. Therefore, there is a freeze response as the child learns that staying in their lane is the best way to survive and avoid threats. This order subconscious classification is a critical phase in a child's education, since unless there is an intervention from an external source, this subconscious order will remain unchanged, causing the child to remain in that placement regardless of changes in the makeup of the learning environments. This means that as the child progresses to higher grades, they will continue to self-assign a similar hierarchy placement. This assignment becomes easier as the school system moves children along a familiar continuum where slow learners remain slow throughout the entire K through 12 learning processes, and high achievers also maintain their ranks unchallenged. This education phase is both the most challenging and the most opportunistic. All children begin school with a winning mindset and maintain their confidence until that classroom reality check. The exact process occurs in the social concept evolving into the ideas of who is cool versus the nerds. Due to this phenomenon, kids do not understand that coolness is more a state of mind than an external assignment or validation stamp. Once children learn their order, they maintain their assignment through role memory. Remember who you are so you don't get hurt. Exercise only within your role boundaries to stay safe. Like a shadow, the amygdala walks parallel to the child, constantly keeping their efforts within safety confinements. If the child attempts to exceed the restricted limits, they are sourly chastised with memory flashbacks that remind them of the potential unpleasantries of trying. When children have emotional experiences, the amygdala codes the memory so that when a future activity triggers the memory, the full experience, including the raw emotions, the related content, and the associated pain, all resurfaces. In light of this fact, it makes sense that academic and emotional content must be balanced and have equal implementation in the instructional process. Any curriculum lacking this balance is incomplete and ineffective. Hence, the data, the scores, the reading disabilities, the economic unpreparedness of our youth, and the overall source of the global education problem. In this video, I have discussed the four structures of the limbic system and their role in human behavior. Even though I touched on some of the influences on education, I will present more implicit implications in the following video to expand on the extent of the impact of children's education as I prepare to transition to the next section. A key question to ponder from this lesson is what the hypothalamus considers a threat. I have presented a lot of information in this session for you to digest. If you have found this information useful, please consider subscribing to my YouTube channel and share it with others you care about. Finally, follow me, Dr. Small, the Academic Architect, PDO, on social media to stay up to date with my journey to restore ethics to education, to provide a fair learning experience for all children. If you want to continue building on the content shared in this video, watch part 2 of this topic. I hope to see you in the next session. For now, goodbye.